One of the things about this tank and the unique part of the design is we have hydronic stabilization. And really what that means is that the tank, essentially in the heated water that we heat up in this large body of water here, creates stabilization. And what that means essentially is that if you have small zones, if you have different zones calling at different times of in the house, what it does is it eliminate the potential of short cycling, where the heat exchanger recovers very quickly, and essentially we're reaching set point and we're not absorbing energy in the heat transmitters in the house itself. So that's one of the really key element in this product versus some of the conventional high efficiency low mass boilers you'll see in the field. This product, with its hydraulic stabilization, not only helps on the domestic hot water production but also on the heat, because we have the stored energy. We store it very efficiently with this high efficiency insulation here, and essentially we backfeed the system and we modulate the pump only to give you what you actually need and eliminate a lot of short cycling that occurs with a lot of conventional low mass boilers. Modulation is really critical in the design of this system because what it does is it balances your loads. This tank is an integrated tank where we're doing two jobs, and what we're trying to do is manage that. And the way you manage it, just giving the amount of input and making your heat exchanger more efficient, is you basically have a modulating input burner. And what that does is as we start sensing that we're taking energy out of the tank, we're only putting a certain percentage of energy back in the tank through the combustion system. So we're not overshooting, we're not firing at one single rate. We are basically only putting in what you're taking out, and that's what modulation is all about, and that's how you create additional high efficiency in your combustion system by matching what you're taking out with what you're putting in. One of the things about the combustion system is that we've designed, as you can see, here's your modulating fan. This is a DC fan that essentially ramps up and ramps down. We have our control board, which is on a slide, which makes the installation or wiring very easy. We even have on the field connection board a low voltage connector which can actually come out, and then the contractor can easily wire it, snap it back in. Everything is labeled, so when you're doing your low voltage, when you're connecting your thermostat wires or your outdoor sensor, everything is clearly marked. These are your line voltage contacts for your outputs. Those are clearly marked, and you can tell by the whole controller can easily slide out, so if you have to service it, if you have to wire it, all the components are easily accessible. Even the fuses are very accessible and can pop out. We have two fuses here which basically give us 4 amp service for each pump output that we have. The fan is easy to get at. You can see our combustion, basically this is our gas valve. Our gas valve adjustment are right here. You can monitor incoming pressure simply by taking a screwdriver on this needle valve and put your manometer over it very easily. We have shutoffs which isolate the gas flow. And then even on the combustion system, here is our exhaust. We're monitoring pressure in the vent system to make sure that we don't have any back pressure or blockage in our vent. We monitor our high limit through this high limit system, and our exhaust has a trap built in which simply allows the condensate, which creates a trap, and the condensate flows out of this connection out of the unit. It's very compact. It's easy to essentially to wire up in the field. We even have on the control, we can pop out the control system, the display itself, and you can operate it in your hand if you need to. We got a multiple display, and we have 20 line character display here which tells you a lot of the features of the system, what your sensors are doing, what your set points are. It's a real nice display, easy to use, and obviously you can even put it in your hand if you need to, and it just pops right into the front of the unit. Essentially, this is a high efficiency combustion system, and what we're doing is we have gas coming in, we have the DC fan, and what we're doing is we're bringing air through this connection here, down through, and we're bringing it into the fan. We're mixing it with the gas. So what we're doing is we're putting that into the head of the burner, and the burner is a mesh burner made of high efficiency material, basically stainless steel, and we're blending it. So when we ignite the fuel through our spark ignition, which is on the bottom here, it gives us a very clean ignition, very efficient operation. And as it travels through the heat exchanger, we come down here through the exhaust, and by the time we come out of this exhaust, the difference between the bottom temperature and the exhaust temperature is within 10 degrees. That's how much energy we're wiping out of that combustion system. So in the main combustion chamber, you could get temperatures in the 1,000 degrees, 2,000 degree mark, and by the time you come out of the exhaust, you're basically what the water temperature is. That's how efficient the operation is. One of the main features of this product here is its space savings. And what I mean by that is essentially the way we design this is that all the components are facing out. So in most installations where you're doing heating and hot water, you have to have two separate appliances. What we did is combine that. And by combining that, essentially, we have a lot of space savings. Not only space savings in the actual equipment, but also space savings when it comes to the connections. A lot of times with low mass boilers, you have to do primary, secondary pumping. And there's a lot of ancillary piping that goes into that equipment room. With this appliance, your combustion system is right up front, and your heating module basically mounts right above it, and you come in and out with your return and supply ports. There's no need for a primary, secondary pumping. So essentially all you're doing is you're going up to your zones with your existing pump, and you're done. That's the beautiful part about this. It reduces cost, labor, and it gives you a nice clean installation when you're finished. It's very simple to install. You have your gas connections, your vent, you have your supply and return going to your heating system. No additional pumps would be needed on that. You could use your existing pumps if you had that, and essentially you're done. That creates a lot of space savings, and it keeps everything in a real compact footprint, and that's the idea of what we're doing here.